Okay, class, right now we're getting ready to start and talk about the EKG, the electrocardiograph, We will discuss it, and after that, I want you to look at the video that I'm going to give. I know this is a video, but a motion video from another individual on the EKG. Now, since this is not an in-class, we won't be doing an EKG, so I won't cover all the topics. I'll just kind of give you a flavoring to give you the basics. You can also read on this in the textbook. So I'm giving you the basics of the EKG. Now, I have two PowerPoints pulled up. This PowerPoint is my EKG PowerPoint, which is in your A&P2 in my private website. And this here comes from Heart 2, the Heart 2 area. So I'm combining these two to kind of give you an overview of the EKG. All right. The topics that I normally would talk about in an in-class would be what's an EKG, the lead system, the paper, the mounting, and so forth. So I'll just brush over. So I'm really more interested in 1 and 2. And then we're going to go over here to the more basic, which would be in my Heart 2 PowerPoint, to just get a flavoring of what it is. And then you also watch the video. All right. An EKG only looks at the charge activity of the heart. Now, the heart has charge activity, which is excitation, and it has motion. It has charge and it has motion. But this only looks at the charge. If I want to look at motion of the heart without invading in, that would be to use an echocardiogram. So the EKG is looking at a summation of the various action potentials occurring in the heart, both in the muscle and the conduction system. You have a lead system, and basically the leads we will call electrodes. And what the leads are doing is looking at the heart. Now, the leads are not directly in the heart. We're not splitting the chest open. So the leads are looking at a distance. So it would be like you're looking at a fire from a distance. And what you're doing is, since you're not right at the fire, in order to get an adequate assessment of the fire of this big house, you would have to have several people stationed around the house, all reporting what's happening on the side, the back, and everything at the same time. So what the lead system involves is really several different lookers looking at the EKG. So you're putting these electrodes on, and these electrodes form the leads. These electrodes form the leads. Now, the leads and electrodes are two different things. The electrodes come together, several of them, to form a lead. You will have some leads on the arms and the legs and some on the chest. Those that have had an EKG, I'm sure, are familiar with that. Okay, so you're attempting to get a look at this. Now, this machine, which is the EKG machine, measures charge activity. And what are you looking at? Charge activity, action potentials within the heart. So this is perfect for that. So that's essentially what the EKG is. It only looks at the charge activity, which means you could have a good EKG and have difficulty walking upstairs because the heart muscle is weak. But the charge system is good. The charge system is good. Okay? So that's what you're looking at there. All right. Now I go over here to the basics. Okay, because here we would get into the paper, the special paper, the mounting, the waves and the segments and various other things. I won't do that. I want to get the basics done this semester for you on this online. All right. So the EKG has certain waves. Now, that means the electrodes would have been placed on the chest and various areas, and then the EKG has certain waves. Okay, this would be the paper, just to show you. It's graph paper. You're measuring action potentials, but a bunch of them. So on this axis would be milliseconds, And on this action would be voltage, just like you have AP1 when you were looking, but you're measuring several. Okay? So that's, here would be a mounted EKG just to show you. And these are the various leads, so you're getting a look from each one just to show you what I'm seeing. Okay? Here would be the standard EKG, which is what you see here. Okay? All right. And so you can use both PowerPoints, but you don't have to get real heavy into this one. I took time to make this a good explanation type. All right. You have these various waves, and they correspond to charge activity in the heart. Not really mechanical activity, but charge activity. But the charge activity leads to the mechanical activity. The charge activity leads to the mechanical activity. All right. So we start out with the P wave. The P wave is what we call atrial depolarization. That means the SA node will come in and fire. The SA node then would send the signal around to the atria. The signal would be depolarization. The P wave would correspond to that atrial depolarization. Now, not atrial systole, because that's a mechanical event, but atrial depolarization. Then, if you may recall, the signal travels down to the AV node, which then ultimately would go down the bundle of His and bundle branches. So this, what we call the QRS complex, has to do with ventricular depolarization. See, here's atrial. Then here would be the time lag between coming from the atrial, traveling down to go to the ventricles. So the QRS complex is ventricular depolarization. You have a Q wave, or shall I say a Q point, an R wave, a S wave. Q point, R wave, S wave. That's the QRS complex. That corresponds to ventricular depolarization. Then we come here and we come out. We had a little where the ventricles then repolarize, ventricular repolarization. So what do we have here? We have the P wave, atrial depolarization, the QRS for ventricular depolarization, and the T wave for ventricular repolarization. Question often comes, well, where is atrial repolarization? Now let's think about this. You're looking at a fire, but you have a small house in front of a big house, and you're at a distance. Because the big house is so massive, the fire at the small house is obscured because you can't see it because you can only see the big house is so big. Since the ventricles are so much larger than the atria, then at the time that atrial repolarization is occurring, ventricular depolarization. And since they are so much larger, they obscure the view of atrial repolarization. Okay? So, here would be the sequence here. Okay? Here's the SA node, which ultimately causes the atria to depolarize. That would give the P wave. Okay? That would give the P wave. Now we're coming to getting to the AV node. Okay, at the AV node, that's this right here, which we call this interval right here. This interval. I'm going to go over here. See this interval right here from there to there? That's that interval, that PR segment. Okay, so that segment that you see here would be the fact of getting the AV node to do its activity. Okay. Then what's going to happen is finally now we're going to pass down the bundle of His, bundle branches, and go to the bottom. As I alluded to, all starts at the bottom because okay. So that would involve the QRS. The difference in deflections would depend on you going down, then up. So see, that's where that QRS, which gives me ventricular depolarization. Okay. Now you're proceeding and you finish ventricular depolarization. So here you are right here. That's that ST segment right there. And you're getting to ventricular. So ventricular depolarization is complete. And now you're moving because you finished the job. That shows you finishing the job. You were doing the job. You're finishing the job. Now you go into the T wave, which is ventricular repolarization, where everything is going back again. And then we're back to normal. So what you can do is follow through the various actions here, as you see, to give you an idea. Now again, remember, that's a normal sinus rhythm. Sinus rhythm means the SA node. I won't get into this. So remember then that the EKG, let's go back, the EKG only looks at charge activity, not mechanical activity. It only looks at charge activity. That I've shown you the progression. This is my EKG PowerPoint. I also encourage you to watch an EKG YouTube video, not just mine, but another one I'm going to give you the link to. And remember that the excitation precedes the contraction. So that means, go in here, that when the P wave occurs, shortly after that will be atrial systole. But atrial systole is a mechanical event. Now, on my next video, I'm going to show you a simultaneous tracing that puts a lot of stuff together at the same time that you need to study, that I've done already. So you can kind of study that. So it'll be on another video. Thank you.